Hello, my name is Micah Ward, and this is the simulation and verification video for the Strategic Kibble Reserve. The purpose of this automated robot is to safely and precisely dispense pet food using a dual actuator mechanism. Looking at the workspace, our main controller is an Arduino Uno. We are using a force-sensitive resistor to weigh the food bowl, a tricolor LED setup for status tracking, a standard hobby servo acting as our oscillating ratchet gate, and a high RPM DC motor representing our main internal corkscrew auger. Because the DC motor draws significant current, it is safely isolated and driven through this L293D H-bridge chip. Let's look briefly at the control software. At the top, we define our pins. Pin A0 for the force sensor, pin 9 for the servo, pin 8, 7, and 6 for our status LEDs, and pin 5 and 4 to control the directional channels on the L293D driver chip. Our threshold target weight is set on an analog value of 400. In our setup, we configure all pin modes and execute a quick startup flash routine on the LEDs. With the simulation running, we manually adjust our force sensor input down to simulate an empty or low food bowl. As you can see, as the weight reading drops, instantly the control logic triggers the bowl low state. The green idle LED turns off, while the yellow warning and red dispensing LEDs illuminate. Simultaneously, notice the DC auger motor turns on, jumping to its max operational scale of over -15,000 RPM to actively pull food down the hopper. Concurrently, the hobby servo executes a continuous indexing stroke, sweeping back and forth from 0 to 180 degrees to keep the mechanical gate clear of jams. Now, as food fills the container, the force sensor registers an increased load. Watch what happens as I slide the sensor input past our target value. It registers the new value and the system transitions seamlessly into the bowl full state. The yellow and red LEDs immediately shut off and the green status LEDs turn back on to indicate safe standby mode. Crucially, the L293D driver drops power to the DC auger motor, instantly bringing its RPM back down to 0, and the ratchet servo completely stops its sweep routine, locking the dispensing gate. This successfully demonstrates that our automated algorithm matches our physical requirements perfectly. The feedback loop dynamically reads environmental weight input, handles dual actuator output without conflicts, tracks states visually via the hardware UI panel, and successfully shuts off to prevent overfeeding once target thresholds are achieved. Thank you for watching the functional review of the Strategic Kibble Reserve.